Hey everybody, this is the first video in a series of tutorials on EasyNet Everywhere. Wireless network EasyNet Everywhere is designed for application in territorially distributed systems, requiring wireless communication with control objects with guaranteed delivery of data packets at a speed of 250 kilobits per second, within a radius of up to 10 kilometers and more. The high technical characteristics of the network are based on its purpose. EasyNet Everywhere is designed to solve various tasks in network projects of different complexity. The network is user-friendly and does not require in-depth knowledge of networking technologies. This allows the user to realize their network projects easily and effortlessly. The EasyNet Everywhere network architecture uses several implementation models, which allows the user to create a network optimally suited for a particular task. The EasyNet Everywhere network implements the following models: Light model, Pro model, Enterprise model. The EasyNet Everywhere network uses network functional nodes: Net Master, Net Controller, Net Node, Slow Router, Fast Router, or Bridge. The Net Controller node is designed for two-way exchange of commands and data between the UART port and the network, for setting the operating modes and states of the controller's function pins, to collect and transmit to the network information from the functional pins of the controller, telemetry. The Net Controller node has the option of connecting a GPS module. This allows you to determine the coordinates of the network node in real time and space and transmit the coordinates to any node in the network. The Net node is designed for two-way command and data exchange between the UART port and the network at speeds up to 921,600 baud. The node does not contain any functional pins. The Net node has UART and Bluetooth interfaces to communicate with the user. The Router node is intended for routing packets in the network according to the established route. It frees other nodes of the network from participation in the process of routing and retransmission of packets. The implementation of the Router node has two variants: slow and fast. Slow router is either in the state of receiving datagram or in the state of transmitting datagram. It is used in networks with low traffic. Fast router is in the state of receiving datagram and in the state of transmitting datagram at the same time. It is used in networks with high traffic. The Net Master node is designed to administer the network, send commands and data to the network, and receive data from the network. The Net Monitor node is a user service tool and is designed to monitor the state of network nodes and manage their operating modes. Each node in the network has its own unique address. In all network models, the full address of a node consists of two components: the network address and the node number. All nodes in the network use an ESP32 microcontroller, NRF24 transceivers, and standard antennas. The choice of transceiver and antenna determines the communication distance between the network nodes. When user data arrives at the UART port, the node immediately transmits the data to the network. In response from the node to the user, receives messages and signals about the result of data transfer. Using the received signals, the user can implement various algorithms to control the process of data transfer. When transmitting streaming data to the network, for example, when controlling a drone, the service signals can be ignored. Preparing the network assembly for operation is straightforward. It is sufficient to connect and configure the node parameters according to the user manual. All devices are connected to the network nodes via the UART serial interface. Computers and microcontrollers can be connected to the network nodes in any combination. Let's move on to practical examples. We need two net nodes, a USB hub, a power supply, and connecting wires. As UART terminals, we will use serial monitor of the Arduino development environment. Let's perform initial settings of the network node parameters. To do this, open two UART terminals, switch on the power. In the terminal, we start to enter AT commands to configure the parameters of the nodes. Let's look at the default node parameters. Let's set the addresses of the nodes, for example, 201 and 202. Set the default recipient node addresses. In this example, each node will be a recipient for another node. Set the speed of the UART port and switch the terminals to this speed. Let's take a look at the set parameters. Everything is fine. Before selecting a working channel, it is necessary to know which channels are free. Let's scan the air and get the result in the form of a histogram. We see that the beginning of the band is occupied. Let's see the list of free channels in the form of a table. Let's set the number of the working channel, for example, number 70. Let's check the performance of the assemblies. To do this, let's run one of the tests that can be used to check the maximum distance of the network nodes. Everything works perfectly. The settings have been configured correctly. Let's run another test and see which channels are used for datagram transmission. In the next test, we will start transmitting packets of 50 bytes from one node to another. Then we will start a simultaneous packet transmission. Let's start transmitting packets of 150 bytes. Test passed. A little message exchange. We can see that the Arduino serial terminal has little functionality. Therefore, let's repeat the node settings using a more advanced terminal. Node addresses, UART port speed, channel scanning, channel selection. Each node in the network can communicate with the user via Bluetooth. This means that all network node settings and node management can be performed via a smartphone from a distance of up to 100 meters. Display the set node parameters on the smartphone. Messaging. Unfortunately, the smartphone screen recorder conflicts with Bluetooth in transmission mode. Display messages of the running test. We can see that the network node works with the UART port in Bluetooth at the same time. This allows the user to monitor the network and control the network nodes in the field. Conclusion: getting your network up and running and configuring network node settings is quick and easy. Thanks for watching. Good luck, everyone.